In this video, we are discussing the easiest type of differential equation. This guy is called linear equations. The linear equation will be the one that you're gonna have pattern, you're gonna have formula in order to solve this differential equation. The difficult thing turned out to be the integration part. Let's take a look at the form of the linear equation. The linear equation will be the equation that you see that is going to be the form dy dx plus pxy equal to qx. So the thing that you're going to identify first is going to be you're going to identify px and you're going to identify qx. And the px will be the term that is the coefficient of y, and qx will be the term that you can have it on the other side, and you're gonna have x alone for qx. So for example, you see example 9, we first gonna identify px and qx. So for px that I use the green color, in this case, you have dy dx plus 2xy, so it's gonna be 2x for px, and you have equal to x e to the negative x squared, so this one is gonna be my qx. Okay, so this one is going to be your px equal to 2x, and you have your qx equal to x e to the negative x squared. Okay, so that my px and qx respectively. The next one, you have y prime plus y tan x equal to sine 2x. So for this one, you see that sine 2x is the term that on the other side alone, so it's going to be qx, and you have the tan x that is going to be the term that multiply with y, so that is going to be your px. Okay, so you have px equal to 10x and qx equal to sine 2x. Okay, so like I said, this one turned out to be kind of easy identify. And let's see example 10. So you see that this one is y prime on the other side, and you have multiply with x squared plus 1. The thing that you need to do is going to be you're going to need to have y prime plus something times y. So let's move. So you see that this one, if you have divide the whole thing by 1 over x squared plus 1, you would get y prime equal to 2x over x squared plus 1 times y, okay? And you're gonna have x to the fourth minus 1 over x squared plus 1. Okay, so that is going to be kind of look like linear equation, but not yet. So you have y prime that you can move to the other side. So you have x squared plus 1y equal to, okay, and this one, let me just simplify this one a little bit. So for this term, it's going to be x squared minus 1, x squared plus 1 over x squared plus 1, and you can get rid of x squared plus 1, so that would give you x squared plus 1 minus 1 on the other side. And see, you're gonna get this guy is going to be your px, and this guy going to be your qx respectively. Okay, so you're gonna conclude that px, I need to highlight negative sign also. Okay, so it's going to be negative 2x over x squared plus 1, and you have qx will be just x squared minus 1. Okay, so that is going to be two things for linear equation. Okay, so this one turned out to be is linear. The next thing that I will teach you is going to be about how to solve this linear equation. The way to solve this linear equation will be you're gonna see that you can put from this form, which is the form of linear equation, into the form that you multiply the whole thing by dx, and you're gonna have this guy multiply with dx and this guy multiply with dx. So you group them together. So you get pxy minus qx dx plus dy. And this one turned out to be in terms of the equation that we have before, that is going to be your m and n respectively. Okay, so let me use the red color and the yellow one. Okay, so the yellow one is going to be here. That is going to be number 1, okay, in front of dy. So that will be your m and n. Okay, so this is going to be m and this is going to be n. So you have the m dy and the n dx. So for the m dy, it's going to be derivative of pxy minus qx. So you find derivative of this guy is going to turn out to be px. Okay, and you have the n dx, which is d1 dx, turn out to be equal to 0. Okay, so this one turned out to be the equation which is not exact, because px not need to be 0. If px turn out to be 0, this guy is going to be too easy. It's going to be just separable equation, and you're going to be able to just integrate them both sides. Okay, so the thing that you have here is going to be a non-exact equation that you're going to find the integrating factor mu. Okay, so we must find the integrating factor mu. Mu will be coming from what? So you're gonna have 1 over n. Okay, so let's do computation. 1 over n dm dy minus dn dx. And you're gonna see pretty clear that this guy turned out to be just px, because dn dx turned out to be equal to 0 and 1 over n equal to 1 in this case. So everything turned out to be just dm dy, which is your px. Okay, so let me highlight some color for you. So that is going to be this pink term. Okay, so that is the term that you have left. So this one will be the function that you use for computing the integrating factor. So it's going to be mu equal to the exponential of integral of px dx that we used to have. Okay, so that's step 1. Let's compute mu for this example. So for computing mu, it's going to be e to the integrate px dx. So for this one, it's going to be e to the integrate of 2x dx. And you integrate 2x is going to be x squared. Okay, so you have mu equal to x squared. Okay, so that is going to be mu for question 1. For question 2, you have mu equal to e to the integrate of 10x dx. Okay, so let's highlight some color for the green one that you can see clearer. So you have px, okay? So it's going to be this guy, okay? And this guy is going to be 10x in this case. So it's going to be 10x, okay? And you integrate 10x, is going to be log, okay? So it's going to be log absolute sec x that I told you before, that you don't need to put absolute, because we just need only one integrating factor. It's going to be just log sec x, and you have e to the log is turned out to be cancelled, so this would give you just secant x. Okay, so e and log will cancel each other. So you have mu in the second case equal to secant x. The next one is going to be, how could we have the solution? The way that we're going to have the solution will be, you see that you have mu equal to this guy. Okay, so you have mu equal to this guy, and you're going to multiply mu to the whole equation. Okay, so you're going to multiply mu to the whole equation. and you multiply mu to the whole equation, and this one turned out to be exact. Okay, so this one turned out to be exact, and the way that we gonna, so this one is gonna be, we just multiply everything with dx. Okay, so I just, let me explain this one again. So I have dx on the bottom here. I'm gonna multiply dx to these two terms that will show up here. Okay, and the thing that we can see is going to be, you see that when you differentiate mu with respect to x, okay, so when you differentiate mu with respect to x, what will happen? When you find the mu dx, okay, so you have mu prime x, so you have mu prime x is going to be just e to the u, okay, so that is the exponential function, so it's going to be e to the u, so this term turned out to be just copy. So e to the integrate px dx. And by using the chain rule, so you're gonna differentiate the inside. So it's gonna be d dx of integrate px dx. Okay, so you differentiate, integrate. So you see that when you differentiate, integrate, they will cancel each other. So this guy and this guy will get rid of each other. So this guy will be just px. Okay, and that will be our result that I wrote here. Okay, so it's going to be the exponential of integral of px dx multiplied with px. Okay, and the nice thing turned out to be, hey, this guy is equal to mu. Okay, so this guy is equal to mu. So it's gonna turn out to be mu px. Okay, it's turned out to be mu px. And this will allow you to know that when you have the mu, it's gonna be mu px dx. Okay, so you have the mu equal to mu px dx. Okay, from this relation, you multiply x up here. Okay, and why this one is nice? Because you have mu px dx, and you also have mu px dx here. And this guy turned out to be d mu. Okay, so this guy turned out to be d mu, so that I change here, and it's turned out to be very nice equation. So you go from here to here by changing mu px dx to d mu. And on this side, you have mu dy plus y d mu. Mu dy plus y d mu is the product rule of d of mu y, okay? And d of mu y will be equal to mu qx dx. So you're gonna integrate both sides, okay? So you're gonna integrate both sides. So integrate and differentiate cancel each other. So you see that you're gonna get mu y, and you're gonna have mu y equal to integrate of mu qx dx. And what would you like to find? You like to find y, okay? How could we find y? You just divide the whole thing by 1 over mu. Okay, so you divide 1 over mu to the whole equation, and you will reach the conclusion here that you're gonna have y okay, so you're gonna have y equal to 1 over mu integral of mu qx dx. Okay, so this one will be the formula for y. Okay, so this one will be formula for y. So for linear equation, you're gonna just have to find mu. Mu will be just the formula up here. Okay, so mu will be just a formula up here, and you're gonna have y, which is the formula down here. So basically, it's gonna be two formula in order to solve the equation, and that's it. Okay, that's used. So you have mu already equal to e to the x squared. Okay, so that I will highlight with the red color. Let's use the red one. So you have mu equal to e to the x squared. So how could we find y? The way to obtain y is going to be you get y equal to the formula is 1 over mu integrate mu qx dx. Okay, so it's going to be 1 over mu integrate mu qx dx. And what is 1 over mu? So it's going to be 1 over e to the x square. Okay, so that will be my mu. So this guy, okay, and you're gonna integrate, okay, you're gonna integrate mu, okay, so it's gonna be e to the x square, okay, which is my mu, multiply with qx, which is the red guy, x e to the negative x square, and you have dx, okay, so that is gonna be my qx, okay. So you see that this is my qx, okay, so the qx here is the red term, I just put them, and I gonna see that you have e to the x square and e to the negative x square, they will multiply together to give you 1, okay, so it's going to be e to the 0, which is 1, so you basically obtain 1 over e to the x square integrate of x dx. The thing that I like to warn you a little bit here will be this guy and this guy not related, okay? You cannot multiply this one into the integral. It's not make sense, okay? So that is going to be just leave it alone. And the thing that I ask you to do next will be when you integrate this one, so you're going to have to leave this guy outside and you put parentheses, okay? So you're going to put parentheses in order to have the integral, okay? So this one will replace with parentheses like this, okay? And you integrate x dx turn out to be x squared over 2 plus c. And that's all, okay? Leave your answer in this form with parentheses, okay? If you drop parentheses, it will mean that you multiply this guy only to this term and it is wrong, okay? So this one, you have this guy multiply to c also, so you need to have parentheses, okay? So that's the thing that I like to emphasize. Okay, and that will be your final answer for linear equation. You see, it's no need to find dm dy minus dn dx find mu, and we have just instant formula, and it's going to be just apply the formula in order to obtain the final answer. Okay, so that I'm gonna move this one a little bit. So I will have more space for doing number 2. For number 2, you get mu already. So let me highlight mu. Mu equal to secant x. So you get y equal to, okay, so you get y equal to 1 over mu, okay, integrate mu qx dx. Okay, so it's going to be this one, and you have 1 over secant x, okay, so it's going to be 1 over secant x, and you integrate, okay, mu is going to be secant x, okay, it's going to be secant x, and you have q. What is q? Q is sine 2x, okay, so it's going to be sine 2x dx. Okay, so it's going to be sine 2x dx, so that will be my qx, okay? And you do what? You're gonna have to compute this integral. How could we compute this integral? We're gonna do this guy by simplifying. Let me make this guy a little bit smaller. I need some space. Resize. Okay. So you see that we need to evaluate sec times sine 2x. So this guy will be 1 over sec x, okay, 1 over secant x integrate sec x will be 1 over cos x, okay, and you have sine 2x. Sine 2x will be 2 sine cos, okay, so it's going to be 2 sine cos, and this one cos and cos cancel, okay, so you integrate sine 2x dx. So you integrate sine is going to be, let me put parentheses, okay, so this one is going to be the integral, so it's going to be 1 over sec. 1 over sec is equal to cos x, okay, so 1 over sec is cos x, and I change from integral to parentheses, and I will integrate sine to, 2 sine x. Integrate 2 sine x is going to be 2 negative cos x plus c, okay, so it's going to be this integral. So you integrate this guy, this is what you get, and then it's going to be your final answer. Okay, so that is going to be your final answer. The final answer will be cos x multiplied with 2 cos negative cos x plus c. So this one you can multiply the whole thing together, so you get negative, okay, so y will be negative cos square x plus c cos x, okay, and that's all. Okay, so that it is linear equation. Let's do the final one. The final one is gonna be you already have px and qx. And for this one, you're gonna find mu, okay? So you're gonna find mu, which is e to the integrate px dx. So you find the integral of the green one, and you find the integral of the green one. So for this case, it's gonna be e to the integral of negative 2x over x squared plus 1 dx, okay? And this one you let u to be x squared plus 1. I have du equal to 2x dx. So this guy will be e to the integral of negative 1 over u du. So it's going to be e to the negative log u, okay, don't put absolute value. So it's going to be e to the negative of log x squared plus 1. Okay, so u equal to x squared plus 1, don't forget that. Okay, so u equal to x squared plus 1. So this guy will be just 1 over u du, okay? And you're gonna just have negative come up here. So it's gonna be log of x squared plus 1 raised to negative 1, okay? And that will be your mu, okay? So your mu will be cancel this guy, so you get x squared plus 1 to the negative 1, which is 1 over x squared plus 1. Okay, so you get 1 over x squared plus 1 for the final answer here. Okay, so you have mu, okay, and I normally highlight mu equal with the red one. Okay, so I have mu equal to 1 over x squared plus 1. So you're gonna have y equal to 1 over mu indicate mu qx dx, okay? And you're gonna have 1 over x squared plus 1, okay? And you're gonna integrate 1 over x squared plus 1 times x squared minus 1 dx, okay? Where is my qx? Okay, where is my qx? My qx is the blue guy up here, okay? And this is your qx. Okay, so that is your qx, and this is your mu. Okay, this is your mu. Okay, I just basically put into the formula. Okay, so I just basically put into the formula. And the thing that you see here is you can flip this one up. So you would get x squared plus 1 and integral. So you see that it's going to be x squared minus 1 over x squared plus 1 dx. Okay, so it's going to be x squared minus 1 over x squared plus 1 dx. And let me just check this guy a little bit. Everything correct so far? Should be, yeah. And the thing that you see is going to be the way to integrate this one. Okay, so the way to integrate this one will be what? Will be, if you recall, so you're gonna have to like a long division for this guy a little bit. So you have x squared plus 1, x squared minus 1. So you divide this one, is going to be 1. Okay, and you have x squared plus 1. Okay, and this one will be negative 2 for the remainder. Okay, so this one will be x squared plus 1. Let's put parentheses in front, and you have the integral. Okay, and you see that when you divide this guy, it's going to be 1, okay, minus 2 over x squared plus 1 dx. Okay, so it's going to be 1 minus 2 over x squared plus 1 dx, because this is the quotient. Okay, so the quotient equal to 1 and the remainder equal to negative 2. Okay, so the remainder equal to negative 2. Let's use other color, pink one. Okay, so that is going to be quotient remainder, and you're gonna just have x squared plus 1, and you would just integrate. Okay, so you integrate. So you integrate, you put parentheses, you integrate 1, you get x, you integrate 2, it's going to be 2 arctan x, okay, plus c. Okay, so that is going to be the parentheses here, parentheses here, and that would give you y. Okay, that would give you y with arbitrary constant c. The next thing that you have is y1 equal to pi. Okay, so you have y1 equal to pi. From y1 equal to pi, okay, since y1 equal to pi, we're gonna find c. We're gonna find c by putting pi here, and this guy will be equal to 1 squared plus 1. Okay, be careful on the calculation a little bit. So you have 1 minus 2 arctan 1 plus z. Okay, so this one will be pi over 2. Okay, and you have 1 minus 2 pi over 4 and plus c. Okay, so this one to come down. Okay, so it's going to be pi over 2. Okay, so you would calculate c. Okay, so you see that c will be this guy together with this guy, so you have c equal to pi, okay, minus 1. Okay, c equal to pi minus 1, and that will be your c that you're gonna have for particular solution. Okay, so let me move the whole thing up a little bit, and I'm gonna be able to write down the particular solution. Okay, so the particular solution would be just y equal to x squared plus 1 multiply with x minus 2 arctan x plus pi minus 1. Okay, so that will be the particular solution. Okay, so this one is a particular solution. Okay, so that's it. Let's conclude. The thing that you need to know about linear equation will be when you see the linear equation, you should be able to identify px and qx. And px will be used to find mu, and qx will be used to find y. Okay, so this one will be the thing that you need to know. And the next topic is about the binary equation. The binary equation turned out to be the equation that we can do the substitution in order to make it into a linear equation. And you're gonna solve the binary equation by these two formula. Okay, so that is gonna be the thing that we're gonna study in the next lecture. Okay, so for this topic, it's going to be just these three examples. Okay, so we're gonna apply them in the next video.